In this problem, we have two football players running towards each other, and they're going to try to tackle one another. So we have a 95.0 kilogram runner running to the right with a velocity of 3.75 meters per second. Then you have a linebacker trying to stop him from scoring a touchdown, running to the left in this case. This person has a mass of 111 kilograms, like I said, running to the left at negative 4.10 meters per second. And they're going to collide. And after they collide or tackle each other, they're going to stick together. And because they're sticking together, this is an example of inelastic collision. So afterwards, I'm going to try my best to draw them stuck together. This person has the ball. This person is trying to stop him. And they're stuck together. So now they are one object. Let me kind of connect their arms, and they have one thing. So we want to find out what's their velocity here. And what's nice about inelastic collisions when they are stuck, they're no longer two separate entities. They're one entity now. So instead of two unknowns, we only have one unknown that we need to figure out. In all collisions, we know that initial momentum is equal to final momentum. It makes life very easy. So remember, momentum is mass times velocity. So we're going to add up for all of these situations. We have 1 here, 2, and then our final over here. So mass of our running back, velocity of our running back, plus mass of our linebacker, velocity of our linebacker is going to equal to our final velocity, or final momentum. So that'll be mass of both of them together. And then let me actually show you what happens. So normally we do write it like this: mass of running back, velocity of running back, plus mass of linebacker, velocity of linebacker, and these are the finals. Well, these are the initials over here. But what's nice, like I said, they're stuck together. So if they're stuck together, this isn't separate. They're actually the same. So if these are the same, what you could do is factor it out. So this velocity final could factor out. So you just have mass of the running back plus mass of the linebacker. And I'm going to use that over here. Mass of running back plus mass of linebacker equals VF. So here's my setup. This is usually your typical setup for inelastic collisions where you have two objects in the beginning, they get stuck together, and then that's your final momentum over there. Let's plug in everything that we know. Mass of the running back is 95.0. I'm going to leave out my units just to make it more tight and fit into the small space that I have. 3.75 meters per second plus mass of the linebacker, 111 kilograms minus or negative 4.10 meters per second is equal to these two added together, which is 95.0 plus 111 VF. Okay, simplify all of them that you can, making sure that you get your signs correct. These are positive, so you have 95 times 3.75, and you get 356.25. I'm not going to worry about sig figs until the end. 356.5 plus 111 times 4.1, and you're left with 455.1 is equal to 95 plus 111, 206 BF. Okay, I'm going to add these two together. Oop, almost made a mistake. Negative. I'm going to add those two together. 356.25 minus 455.1, and I get negative 98.85. I'm going to worry about units now just to make sure that we get the right correct end. So here you have kilograms, here you have meters per second. So this is kilograms, meters per second. Momentum doesn't have a specific unit like newtons or anything like that, so it's just kilograms, meters per second. This one is mass over here, 206 kilograms. VF, so when you divide it, negative 98.85 divided by 206 kilograms. The kilograms cancel out and you're left with meters per second is exactly what we want. So this divided by 206 and you get negative 0.47 985 equals velocity final. We started with 3 sig figs. I'm just going to end with 3 sig figs. So 8 rounds that up. So you have 0.480 meters per second equals velocity final, and it is negative.